Hi and welcome back to Sustainable Teacher. If it is your first time here, my name is Leticia and I'm glad to meet you. And if you've been here before, I'm happy to see you again. In today's video, we are going to learn the basics of mechanisms. What is a mechanism? And simple mechanisms that you use every day even without knowing. If this video sounds interesting to you, please subscribe, hit the notification bell, and if you like this video, give it a thumbs up. As always, the first question is, what is a mechanism, right? So a mechanism is just a part of a bigger, a complex machine. Sometimes even there are some mechanisms that could be just as themselves simple machines. And the objective, the function of a mechanism is doing a work. Usually they transform any type of energy or some type of energy like electricity or heat into kinetic energy, into movement, okay? That is in general terms. Probably if I asked you to tell me an example of a mechanism, you will answer or pulleys or levers, because they are like the typical ones, the typical examples, but there are some mechanisms that are even simpler, okay? Which are those really simple mechanisms? Well, we have, even if you don't think that is a mechanism, inclined planes are just ways to skip steps, okay? So you put like a ramp or like a slope, and that will help you to move a heavy object from the bottom to the top or from the top to the bottom. Another example of simple machine, it could be the wedge. A wedge is just like a conical piece that will help you to split something in two, like in this example with the hammer and the trunk. Another very typical example, this is a bit more complex but still simple, is the wheel and the axle. So you have a wheel and an axle to move the wheel. You will be able to move an object easily with this rotational movement. And finally, the fourth simple machine is the screw. And the screw is just an object like this, but you can use the shape of this screw to move things easily or with less effort than if you are trying to move them directly. A typical example is the Archimedes screw, which is a screw that was used to move water without effort or with less effort than normally.
¿Qué piensas? ¿Qué te propones, Arquímedes? ¡Eureka! ¡Lo encontré!
But as I told you at the beginning of this video, the example by excellence of a simple mechanism is the lever. A lever is just a bar, a rigid bar, with a support point called fulcrum. And from that fulcrum we have two arms, it's like just the two parts of the bar. One is called the load arm and the other one is called the effort arm. The load arm is the one that will support the weight, and the effort arm is the one you use to push or pull and move the object that it is in the load arm, okay? But depending on the combination of the location of the fulcrum and the effort and load arms, there are different classes, different types of levers. Actually, there are three main types of levers. So it's just first class, second class, and third class. Let's see an example of each one of them. So the first class lever is just the classical one, is the one that you will have on your mind if I tell you, think about how a lever works. So the fulcrum is in the middle, and one arm is this is what I already explained to you. So it's like the load arm and the effort arm. In this case, in this example, it's just this boy trying to lift this box with this bar, and the fulcrum is the pile of books, okay? The second class lever is a bit different because the fulcrum is in one side of the bar, and actually the load arm and the effort arm are like the same part of the bar. They are not, the fulcrum doesn't divide the bar into two arms, okay? But it doesn't matter, we can identify where is the effort and where is the load. In the case of class 2 levers, the load is between the fulcrum and the effort part, because we are doing the effort from the opposite side of the bar, okay? It's the case of this wheelbarrow, okay? So the fulcrum is the wheel, the load arm, or the part that supports the load, is the barrow, of course, and then the handles are the effort arm, is the place where you put your effort, where you put your work, your energy to lift that load. And in the case of the third class levers, the effort and load parts are inverted, okay? They are flipped. So the fulcrum is still in one end of the bar, in one side, but in this case the effort is done in the middle and the load is in the other end, in the other part, in the other side of the bar, okay? In this case I gave you an example of a fishing rod, okay? So your hands are like the fulcrum, and at the same, and the load is in the opposite part of the rod, because the fish, of course, is there. And then when you push, like the effort is done in the middle of the rod, and that's why, because I told you that levers are rigid. Actually, this is not a rigid example, but we can accept this. And if you see when someone is fishing, the rod tends to bend in the middle. So that's why this is the point where the effort is located. And I'm afraid we have a final formula in this video. I want to teach you how to apply the formula to calculate the force in levers. Even though I'm gonna give you a link in the card below to a simulator where you can play with this in a very intuitive way, and you will understand better what means each part on the formula, okay? So it won't be that difficult for you. In this case, the formula is F multiplied by a small case d equals to P multiplied by D in capital letters. What means each letter? So F is the effort for the effort, that the force I need to apply to move the object in the poly, okay? D is the length of the effort arm. And then we have P, which is the resistance for the load, the weight of the object. And D in capital letters is the distance of the load arm, okay? And we're going to apply this in a first class lever because it's the easiest example and it's the one that you will find in the link below. So let's do a final exercise. In this case, it's gonna be a lever exercise, and the given data in the exercise is as follows. So the distance in the effort arm is 3 meters. By the way, distance should be always given in meters, okay? And that is the D in small letters. Then we have the effort force, that is the F. And forces should be always given in newtons because this is the unit for forces, in case you don't know it. And it's 200 newtons. So now we have all the information for the effort part. Let's see the information for the load part. So we know the length, which is D, for the load arm, and it is 1 meter. And the question is, what is the resistance force? That is the P, okay? That is the load. And we are going to apply the formula, which was F multiplied by the small d equals to P multiplied by the big D, okay? So let's isolate P because this is the value that we don't know, and we should multiply F by D the small d divided by the big D. That is 200 newtons multiplied by 3 meters and then divided by 1 meter. Of course we won't divide by 1, but I just want to show the formula as it is. And meters with meters will disappear. So we have 200 newtons multiplied by 3, which is 600 newtons. In the beginning, I told you that we use mechanisms to transform any type of energy into motion. So one good question could be, which type of motions do we have, or in which type of motions can we transform the work we are doing with those mechanisms? So of course the easiest one is the linear motion. It's just moving in the same direction and the same sense of the work. In the case of a train, well, actually the train is not a mechanism, it's a machine, because there are a lot of different types of mechanisms inside, okay? But the result of the movement of all these small mechanisms is the linear motion, okay? Then we have the rotary motion, which is the rotational, like moving in circles, like wheels, in a train, in a car. Then we have reciprocating motion. It's a weird word, but it just means going back and forth, back and forth, back and forth, back and forth, okay? So it's like doing the same motion in two senses all the time. Then we have oscillating motion. It's similar to the reciprocating motion, but instead of using the same direction and moving in different senses, it's a mix between rotary and reciprocating motion. So it moves in a rotary way, but it is not a full circle, it's just like one arc, and it goes from one point to the other point, one point to the other point. So it's the same, it's back and forth, but it's not linear, it's circular. And the last example of type of motion, or of the main type of motion that a mechanism could do, is intermittent motion. That means that it is not always moving, it moves sometimes. And that's all for today. I hope that now you understand better, or at least you have a better definition of what is a mechanism, which type of simple mechanisms we have, and of course the movements that we can get from a mechanism. Leave in the comments if you knew that an inclined plane or even a wedge could be considered as simple mechanisms, or if you already knew this, or if you have any kind of doubt, please leave it in the comments as well. And of course, see you soon.